So welcome back, and we are continuing with our study of Euclidean geometry. Let's dive straight back in. We're on page, let's just have a look, we're on page 17, and the first question here requires us to test and show whether these triangles are similar. Now remember, there are two ways of proving triangles similar. One is to have all the angles equal, in other words, angle, 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 and another is to look at the ratios of the corresponding sides. So if we were to take the longest side in this bigger triangle, 8 over the longest side here, 8 over 5, all right? And then let's also work out the shortest side divided by the shortest side. That would be 3,6 over 1,8. Now 3,6 over 1,8 is actually exactly 2, all right? 8 divided by 5 is not 2, it's actually 1,6. So in fact already they're not similar. Okay, we could just check the last one. Sorry, the longest side here is actually not 8 over 5, it's 10 over 5. So far they are similar. We still need to check the last side. 10 over 5 is 2, my apologies. Right, and if we take the middle length side, now the middle length side is 8 here and it's 4 here. So in fact 8 over 4 is equal to 2. So therefore, yes, they are similar. Now when we write them down, we're going to write them down in the correct corresponding order. Doesn't matter which order we write down our first one in. Let's go with ABC. Similar. And now it is important that we now check that we get the right corresponding order. If we look at ABC, we went down the middle length side, then down the shortest side. So we need to do the same here. In fact, we're going to go FED, triangle FED. Okay, and the reason for our similarity, and this is really, really important, is that the corresponding sides are in proportion. Okay, right, so that's question 1. Let's look at question 2. Again, if you haven't tried these questions, please pause the video first, then try them, and then let it play and see how you go. So two triangles are similar if they are equiangular. By equiangular, we are saying that they share the same size angles, right? And the shorthand for that would be AAA. Or if their corresponding sides are in proportion. Those are the two conditions for similarity. Yeah, and this kind of shorthand for that we write up here in green. If a line cuts two sides of a triangle in the same proportion, right, then it is parallel to the third side. And that is in fact the converse of the proportional intercept theorem. Okay, parallel to the third side, sorry. Okay. Right, let's turn over and see what we've got next. This one says, let's see whether these are parallel. So again, we're going to do exactly as we did last time. We're going to take the biggest side. Right, there's the biggest, sorry, that's not the biggest side. The biggest side, 10,7, divided by the biggest side here. 10,7 divided by 7. Okay, we're going to work that out. Then we're going to take the middle sized side, right, which is 9 divided by 6. Now 9 divided by 6 is exactly 3 over 2. And the last one, 4.5 divided by 3, that's also 3 over 2. 4,5, sorry, over 3 also works out to 3 over 2. Now, 10,7 over 7, I do not believe is 3 over 2. Right, it's close, but it's not 3 over 2. We can quickly check with a calculator. Go 10,7 is in fact 1,53. So although it's close, it's not actually equal. So therefore, triangles not similar. And if we wanted to give a reason for them not being similar, we would say that the corresponding sides are not in the same proportion. Okay, 3b, are these triangles similar? And now you'll notice that we're now integrating some of our circle geometry. And these two absolutely are similar because this angle over here is equal to this angle over here. Let's write down y. Angle A equals angle E. Our reason is angles in the same segment. Okay. Similarly, angle D is equal to angle B. So these two are equal. And the reason for that again is angles in the same segment. Angle D equals angle B, angles same segment. Okay, and then lastly, angle C1, and normally these little numbers will be included on the diagram, but we can add them in ourselves if they're not there. Angle C1 will equal angle C2. And there's actually two different reasons we could use here. Those are the third angle of the triangle, right? So in other words, if two angles are equal, then these two must be equal. So we can write third angle of triangle. Or the other reason, obviously, is that these are vertically opposite angles. Okay, now we've got three angles, and when we've got three angles, we can conclude that our triangles are similar. Again, remember, very important that we list them in the correct order. So let's go with ADC, ADC, right? Now if we look at ADC, that we started with that angle, so we must start with the angle that's equal to that angle. We must start with angle with E, then we went down to this one with the two red arcs on, so we must go to B, and then lastly to C. Okay, so there shouldn't be an angle mark on there. This is a triangle, not an angle, right? And our reason, and this is really, really important, our reason is angle, angle, angle. Okay, and that's a proving of two triangles similarity. And we're going to do loads and loads of examples of that. Okay, let's look at the next one. In here, there are actually three triangles, right? There's this one over here. There's this one over here. And there's the big one. Right, so now we're going to just have to do a little bit of thinking as to which two are in fact similar. Okay, let's have a look. Well, if we look at the big one and the smaller one over here, I'm going to just shade it yellow. We look at the big one and the yellow one. They share an angle. So straight away, we already know that they have angle S equal to one another. Okay, but I'm not seeing anything else, right? What about the big one and this one? Right, now the big one and this little blue one, they share an angle too. But we've got a tangent. And that tangent tells us that, in fact, this angle over here is equal to this angle over here, tan chord theorem. So now, if we're looking at the big triangle, the whole triangle, and the blue triangle, we've actually got two angles. We've got this one that's common, and we've got another one. And if we've got two angles equal in triangles, the third one must be equal. Let's write all of that down. Okay, so it's quite helpful if we start off by saying which triangles we're talking about. In triangles ART, A-R-T, that's the blue one, and the big one, which we'll call SAT, At the moment, we're not worried about the order. Okay. What we know is that angle T is common. We also know that angle A1, and I'm going to call it A1, is equal to angle S. And the reason for that is tan chord. And we also know that the remaining angle, the angle we haven't spoken about so far in this triangle, is this angle. And the angle that we haven't spoken about so far in the blue triangle is this angle. Those two must be equal. So let's write that down. So we know that angle SAT is actually equal to angle ART. And the reason for that is that those are the third angles of triangle. And now we have got three angles. Because we've got three angles, we can write down that these triangles are similar. So therefore, triangle, doesn't matter where we start. Let's start with A, right? If we start with A and we go to R to T, that will be similar to triangle. And what we've got here now, from A was this one with the green arc on, so it must be equal to S. Then ART. We now go to this angle with the red arc on. So in the big triangle, we must go to the angle with the red arc on. So we're going to go to A, and notice we end off at T with both of them. T is that common or shared angle. The reason for our similarity here is AAA. Angle, angle, angle. The only two reasons for similarity, either three angles equal like that, or corresponding sides in proportion. Okay, let's try this one. In fact, in this diagram, there are actually three triangles. I'm going to call them 1, 2, and the big one. Right. Now, we can actually quite easily see that all three of them are in fact going to be similar. Okay, and this is actually a result that we can use later, and we'll show you the reason you can give for that. But I'm just going to show you why, in fact, all of them are similar. Suppose this is X. Now, in this little triangle over here, we've got an X and we've got a 90. This must be 90 minus X, right, to make up the 180 degrees in triangle 2. But if we look now, in the big triangle, here we've got a 90 minus X and a 90. So this little piece must be X for these two to add up to 90. Now here we've got a 90 and an X. So this one here must be 90 minus X. And so if we look at the three triangles, each of them has got an X, a 90, and a 90 minus X. So in fact, all three of them are going to be similar. Let's start with the little one, start with triangle number 1. Okay, so if we went triangle D, C, B. Now we're going to show that it's similar to the biggest triangle. So D is obviously shared, so we would start at D. Then if we look, we went from D to the 90-degree angle. So in the big triangle, we must go to the 90-degree angle next, which is at B, and that would be A. And this would be similar. Now if we look at DBA, the big triangle, right, we starting at the one that's 90 minus X. So we're now in triangle 2. The angle that's equal to 90 minus X is B. We go to the 90-degree angle, and the 90-degree angle is at C, and then we go to A. And you'll see that these two A's are in the same place because that's the common angle. The reason, we've proved this now by angle, 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 but in fact we can also say perpendicular from 90-degree angle. Right, so in other words, if we've got a right angle triangle, let's just draw a right angle triangle. Right angle triangle, okay. Let's try and draw that quite nicely, like that. And we draw in a perpendicular. In other words, we drop from this right angle we drop a perpendicular. Okay, then all three triangles, this one, number 1, number 2, and the big one, will all be similar to one another. And we can use this as our reason. Okay, we've actually proved it up here. We've shown that it will always be the case. Okay, right. Now we're going to stop there. Before the next lesson, try the remaining questions. In fact, maybe try the questions on page 20 and 21 and maybe even 22, and we'll look at those next time. All right, have a great day. We look forward to seeing you then.